Video opens with an animation of a stylized human brain. Lines of light pulse through it, forming interconnected nodes, representing a neural network. Have you ever wondered how your phone can finish your sentences or how voice assistants understand your commands? The magic behind many of these incredible technologies lies in a special kind of artificial intelligence inspired by our own minds, recurrent neural networks, or RNNs. These powerful models are the key to teaching machines how to understand sequences just like we do. From translating languages in real time to recognizing spoken words, RNNs are revolutionizing how we interact with the digital world. So, how do they work? Imagine you're reading a book. You don't just understand each word in isolation. You understand it in the context of the words that came before it. Simple neural networks struggle with this because they treat every input independently. RNNs, however, have a special trick up their sleeve, a loop. As an RNN processes a piece of data, like a word in a sentence, it doesn't just produce an output. It also passes a piece of information to the next step. This memory is called a hidden state. It acts like a summary of what the network has seen so far, allowing it to understand context, patterns, and sequences over time. This continuous flow of information is what gives RNNs their power to process sequential data. However, the basic RNN architecture has its limits. Think about trying to remember the first word of a very long paragraph. It's difficult, right? Similarly, simple RNNs struggle with long-term dependencies due to a problem known as the vanishing gradient. This means the network's memory can fade over long sequences, making it hard to connect distant pieces of information. To solve this, brilliant minds developed more advanced architectures. Enter long short-term memory networks, or LSTMs. LSTMs have a more complex internal structure with gates that control the flow of information. These gates can learn what information is important to keep and what to forget, allowing the network to remember relevant context over much longer periods. A similar, more streamlined architecture called a gated recurrent unit, or GRU, also excels at this task, offering a powerful yet efficient alternative. The real-world impact of these networks is staggering. When you use Google Translate, NRNN is likely working behind the scenes to understand the grammar and context of your sentence before translating it. When you see a social media platform analyzing whether a comment is positive or negative for sentiment analysis, that's often NRNN at work. They can even generate descriptions for images, a task known as image captioning, by identifying objects and describing their relationships in a coherent sentence. Looking ahead, the potential for RNNs is vast, promising even more sophisticated applications in fields from personalized medicine to financial forecasting, fundamentally changing our industries. To wrap it all up, recurrent neural networks are a fascinating type of AI that uses internal memory to process sequences of data, making them perfect for tasks involving language and time. While simple RNNs have limitations, advanced architectures like LSTMs and GRUs have overcome these challenges, unlocking incredible capabilities that we use every single day. The world of machine learning is always evolving, and RNNs are a cornerstone of that progress. We hope this gave you a clear look into the amazing world of RNNs. If you're curious to learn more about the technologies shaping our future, make sure to subscribe to our channel and hit the notification bell. Thanks for watching, and we'll see you in the next one.